You wake up in the morning, right?
Yeah.
And you're groggy, you reach over, and you smack your hand down on the solid wood of your nightstand to turn off the alarm.
Yeah, and it usually hurts a little.
Right. Because the wood is hard, it's cold, and it is undeniably physically there. That physical touch feels like the ultimate foundational proof of reality.
We just assume that the world exists exactly as we feel it, even when we leave the room and stop touching it.
But today, in this deep dive, we're going to look at a massive stack of sources that completely dismantle that assumption. I'm talking cutting-edge quantum mechanics papers, cognitive psychology, ancient philosophy, and even dense engineering frameworks.
Yeah, they are all kind of converging on this one wild idea, the idea that you might be actively creating the universe simply by waking up and looking around.
Exactly. We're going to tear down the wall between you and the universe today. No dense math equations, just simple terms. But before we get into the mechanics of how that actually functions, here is the question we need to start with.
If nobody is looking at the universe, does it even exist? Yeah, that is the big one. And to even begin to answer what the universe is made of, we first have to examine the very equipment we use to perceive it.
You mean our senses, right?
Right. We tend to assume our eyes and ears are passive receivers, like cameras or microphones just objectively recording the truth of the world. But cognitive scientists are arguing that this is physically impossible.
Yeah, Donald Hoffman's interface theory of perception makes a really compelling case here. He argues that evolution did not train us to see the truth of reality. It only trained us to survive.
Exactly. Because rendering the actual complicated truth of the universe would require way too much biological processing power.
Right. Like if an early human spent their time calculating the exact quantum state or the atomic structure and light refraction of an approaching tiger.
They just get eaten.
Yeah.
Yeah.
Their brain would be so overrun with data processing they wouldn't move. Evolution favored the organism that filtered out like 99% of reality, perceived a terrifying simplified shape, and ran.
Hoffman actually uses evolutionary game theory simulations to prove this. When he runs computer models pitting virtual organisms that see objective truth against organisms tuned strictly to survival fitness, the truth-seeing ones go extinct every single time.
Every time.
Every time. Survival requires a massive compression of data.
One of our sources uses a brilliant analogy for this compression. Think of your computer desktop. If you want to delete a document, you drag a little blue folder icon into a little trash can icon.
Right, but if you were to unscrew your computer monitor and look at the hardware, you wouldn't find a tiny blue folder.
Exactly. You just find silicon, circuits, and microscopic electrical charges. The blue folder is entirely an illusion. It is just a user interface.
And that interface is incredibly efficient. Whether you're looking at an apple on your kitchen counter or measuring a subatomic quark in a lab, you're interacting with an icon on your brain's mental screen.
So when you close your eyes, that specific representation, like the red, shiny apple, it ceases to exist as a visual object, even if the underlying code of reality remains.
That's where the philosopher Merleau-Ponty comes in with a framework called 4E cognition. It argues that perception isn't something that happens to us passively. It's an active, physical process.
Yeah, he uses the example of a blind man navigating with a cane, right?
When the man first picks up the cane, it's a foreign object. He feels the handle pressing into his palm. But as he uses it to tap the pavement, neuroplasticity takes over.
The brain actually remaps its own physical boundaries.
Exactly. The man stops feeling the handle of the cane entirely. It becomes a literal neural extension of his body, and he starts feeling the world at the tip of the cane.
The boundary between the human subject and the outside world physically shifts based on interaction. And Alvin Newey applies a similar logic to something as simple as a tomato.
The tomato analogy is great. A tomato doesn't possess one objective intrinsic color or shape.
Right. Its physical properties, the wavelengths of light it reflects, its curves, they change entirely depending on the lighting in the room and the angle you view it from. The tomato is relational.
Its visible reality is actively constructed by your relative position to it.
Okay, let's unpack this, though. If everything I see is just a survival interface, just icons on a screen, what is the actual hard drive made of? Is there a physical, objective world out there at all? Or is reality just entirely in our heads?
Well, if everything you see, touch, and hear is just a biological illusion designed to keep you alive, what is hiding behind the screen?
Man. Okay, so if biology tells us perception is an active construction, how does physics handle this? Because physics is supposed to be the hardest of the hard sciences.
Right, but when we transition from the biology of human perception to the physics of observation, The solid world disappears all over again.
Which brings us to the physicist John Wheeler and his concept of the participatory universe. We used to model the universe as this giant mechanical clockwork system ticking away independently.
Wheeler pointed out that we treated reality as if we were standing behind a thick, 1-foot slab of plate glass, safely separated from the universe, just watching it happen.
But quantum mechanics shattered that glass.
Literally shattered it. At the subatomic level, in order to measure an electron, you have to interact with it. You have to bounce a photon of light off of it to see where it is.
And that very act of measurement transfers energy and permanently alters the electron's trajectory. You cannot look at the universe without fundamentally changing it.
Which means we are no longer observers. We are participators.
And this isn't just theoretical anymore. We have a source breaking down a recent quantum computing experiment run by IBM, testing the Wigner's friend paradox.
Oh, this experiment is mind-bending.
It really is. So imagine a scientist inside a sealed laboratory. They measure a quantum coin flip, a particle in a state of superposition, meaning it's mathematically spinning as both heads and tails simultaneously.
Right.
The scientist measures it, the superposition collapses, and they record a definite result. Heads. That is a hard, physical fact for the scientist inside the lab.
But the paradox focuses on the friend standing outside the sealed laboratory. To the person on the outside, the scientist, the lab, and the coin are all part of one giant closed quantum system.
Because they haven't observed the result yet.
Exactly. So the mathematics state that the entire laboratory is now in a state of superposition. From the outside perspective, the scientist has simultaneously measured heads and measured tails.
Classical physics would demand that one of those perspectives is wrong. A coin can't be a definite heads inside the room and a blurry heads and tails outside the room.
But the IBM experiment literally proved that both observers are mathematically and physically correct.
Wait, really? Both are correct?
Both are true in their respective realities. Two different people can observe the exact same quantum event, get completely contradictory results, and both facts are true. There are no observer-independent facts.
That is insane. The universe customizes its physical state to each individual observer.
It does, and this creates a massive problem for physicists known as the Heisenberg cut. It's the theoretical boundary line where a blurry quantum possibility snaps into a solid, definite reality.
So where does that cut actually happen? Does the universe only solidify when information hits a human retina?
Well, in a framework called relational quantum mechanics, Carlo Rovelli argues there is nothing biologically special about human consciousness. A bird flying through space, interacting with light, counts as an observer.
I read in another source that a highly advanced human-level AI processing sensor data would also collapse the wave function. Anything that processes information forces the universe to render a reality. So reality operates remarkably like an open-world video game. The map only renders the complex graphics of the trees and mountains when a player turns the camera and looks at them.
Exactly, because otherwise it would just waste processing power.
Right. But if a bird counts as a player, and an AI counts as a player who is hosting the server.
Wheeler pushed this even further with his delayed choice thought experiment. It shows that how you choose to measure a particle today can actually retroactively determine the path that particle took billions of years ago.
So if observation literally retroactively determines the state of the universe, are we creating the past right now, just by choosing how we look at it today?
It's a lot to wrap your head around. But if the universe only renders when a player looks at it, we have to entertain this wild idea from the field of digital physics.
Yeah, Vlaco Vedral explores this in his book, Decoding Reality. He argues that the fundamental building block of the universe isn't matter, like atoms or quarks.
And it isn't energy either. The foundational building block is quantum information, qubits.
As Wheeler famously summarized it, it from bit.
Right. Everything physical comes from information.
To understand the math here, think about calculus. Calculus tries to measure the universe as a smooth, continuous thing that you can divide infinitely. But at the quantum level, that creates impossible infinite energy equations.
The math totally breaks down. To fix it, you have to treat reality like a digital photograph. From a distance, it looks perfectly smooth.
But if you zoom in far enough, it's not smooth. You hit a limit. It's made of rigid, finite pixels.
In physics, that ultimate pixel is called the Planck length. It's the smallest possible grid square of physical space. You can't divide space smaller than a Planck length, just like you can't have half a pixel on your screen.
Reality is pixelated. And this concept is mapped out in one of the densest sources in our stack, a theoretical engineering framework called the Cosmoplex Primer.
Oh, the Cosmoplex. That is a heavy read.
Very heavy. It models reality as an 8-dimensional recursive lattice. And while our computers run on binary code, just zeros and ones, the Cosmoplex argues the universe requires a ternary code.
Meaning it uses 3 states, -1, 0, and +1. A ternary system allows for much more complex geometry.
Yeah, a 0 provides empty space, while a +1 and -1 provide positive and negative charge, allowing waves to interfere with each other.
And the Cosmoplex framework claims that absolutely everything in existence is built from exactly 42 fundamental computational patterns, which they call glyphs.
Those 42 glyphs interact mathematically to generate the illusion of physical matter, gravity, and light. It even parfaitement derives the fine structure constant.
The 137.036 number.
Exactly. In physics, that constant dictates exactly how strongly light interacts with matter. If it were slightly different, atoms couldn't hold together, the universe would disintegrate.
Physicists have measured this number for decades, but had no idea why it was that specific value. The Cosmoplex derives it purely from its geometry, arguing it's a strict thermal and processing limit for the cosmic computer.
Now, I need to point out that there's a sharp divergence in our sources here regarding the philosophy of all this. Buell and Koskin takes this computational model and argues that it points definitively toward intelligent design.
Yeah, he critiques popular science figures for promoting what he calls poetic naturalism.
Right. He claims they are gaslighting rational observers into ideological atheism by ignoring the clear engineering required to build this system. And just to be totally clear to you, the listener, we are not taking a side on this debate. We're purely reporting the arguments presented in the texts.
Absolutely, because other physicists in our stack vehemently disagree, arguing these rules are just the inevitable result of quantum selection over infinite time.
But here is where it gets really interesting, but also a bit scary. If the universe is just a machine running an algorithm, doesn't that completely destroy free will?
It forces you to question your autonomy, for sure.
Are our choices, our mistakes, and our loves just lines of code executing flawlessly on an 8-dimensional motherboard?
Well, if you were nothing more than a highly complex software program, does that make your feelings, your pain, and your love any less real?
Oof. But if we are just conscious code running inside a participatory universe, how does our subjective internal mind actually interface with that external physical code? Can the system glitch?
To understand that glitch, we can look at the psychiatrist Carl Jung and the Nobel Prize-winning physicist Wolfgang Pauli.
The synchronicity guys.
Exactly. They developed the concept of synchronicity, which they defined as meaningful coincidences that lack any physical cause and effect relationship.
Jung's famous anecdote is so good for this. He had this stubbornly logical patient who was resisting therapy. During a session, she starts describing a deeply symbolic dream about being given a golden scarab beetle.
And right as she is speaking the words, Jung hears a frantic tapping at his office window.
He opens it, and a real scarabade beetle, a rose chafer, which is the closest thing to a golden scarab in Europe, flies directly into the room.
He literally catches it, hands it to her, and says, "Here is your scarab." That event completely dismantled her rigid worldview.
Jung and Pauli hypothesized that during periods of extreme psychological tension, the strict boundaries of space and time become momentarily elastic.
The internal architecture of the mind and the external architecture of the physical world temporarily sync up. The boundary between observer and observed dissolves.
It's easy to view that purely through a mystical lens, but our sources provide a real biological mechanism for this, the reticular activating system, or RAS.
The RAS is this bundle of nerves at the base of your brainstem that acts like an extreme data filter. Every second, your sensory organs send about 11 million bits of information to your brain.
But your conscious mind can only process about 40 to 50 bits per second. That means the brain is forced to throw away almost all of reality just to function.
And the RAS decides which 40 bits get through based on what you have primed it to look for.
Right. So if you constantly notice the time 11.1 on the clock and decide it holds spiritual significance, your RAS flags that pattern as vital for survival.
You're probably looking at the clock at 3.14 just as often, but your RAS filters it out as irrelevant noise. Our brains are meaning-making machines desperate for symmetry.
And this psychological filtering becomes incredibly consequential when we introduce modern algorithms into this participatory universe. There's a crucial study in our stack called the mirror-mirror study.
Oh, this one is fascinating. It looked at what happens when humans allow algorithms to define their identity.
Yeah, researchers assigned humans a predictive score generated by an AI, like they'd predict the human would be a low performer at a specific task.
The crazy part is the algorithm's prediction could be completely flawed or just randomized. But when the human views that low score, a psychological mechanism called moral wiggle room activates.
The human subconsciously anchors their internal belief system to the external computer's prediction. They assume the algorithm knows them better than they know themselves, and they decrease their effort.
The algorithm didn't just predict their behavior, it actively manufactured it by altering their expectations.
So it's a massive feedback loop. We look at the algorithm tells us who we are, and we subconsciously rewrite our own code to become it. The map literally becomes the territory.
So are you living out your own destiny, or are you just fulfilling the mathematical expectations of the systems observing you?
Man, when we pull all of these diverse fields of study together, a singular, cohesive narrative really emerges.
It really does. We started with the biological reality of Donald Hoffman's interface theory.
Learning that human perception evolved to hide the complex truth of the universe behind a simplified, everyday, tomato-like survival screen.
Then we looked at the physics behind that screen, exploring Wheeler and Wigner's friend, realizing the quantum world remains in this blurry state of infinite potential until an observer participates.
We examine the mathematical mechanics of that rendering process through digital physics and the cosmoplex.
Seeing how the universe might function as an 8-dimensional...
We explored how our internal minds interface with that code, filtering 11 million bits of data down to 40, experiencing synchronicities like beetles knocking on windows.
The strict line between the subject you and the object the universe is entirely gone. You aren't a passive audience member sitting separate from the universe. You are the universe actively looking back at itself.
Which leaves us with one final, profound implication.
Yeah. If this universe absolutely requires an observer to render it into existence, and you are a piece of that universe, who or what was observing the universe to bring you into existence in the first place?
I want you to spend some time chewing on that concept. Please drop down to the comment section below and leave your own thoughts on the deep philosophical questions we've explored today. Who do you think is hosting the server? What is actually hiding behind your screen? And while you were down there, please remember to like this video and aggressively hit that subscribe button so you do not miss our next deep dive. So tomorrow morning, when you wake up and your hand hits the cold hardwood of your nightstand, just remember, it might just be the universe rendering exactly what you expect it to feel.